Welcome back, everyone. Today we're diving deep, really deep, into a topic that's absolutely fundamental, especially when we're talking about the complexities of marine engineering and operations, risk management and safety.
Right.
We've gathered a ton of material for this one, everything from, those core principles of how we even assess risk to the really specific safety procedures for all sorts of equipment and even some really fascinating case studies. I think our goal today should be to really dissect all of it layer by layer so you come away from this deep dive with a real grasp, not just on like what needs to be done, but the why behind it all.
Yeah, I think that's right. And what we're really looking at here isn't just like a bunch of rules or a checklist or something like that.
Mm-hmm.
It's really more of a fundamental approach, a mindset almost, that you need to bake into every single stage of an operation,
Okay.
from that very initial planning phase all the way through that final execution.
Right.
And a really central idea that our sources keep hitting on from the very start is this principle of accepting no unnecessary risk.
Okay, so let's unpack that a bit. Accept no unnecessary risk.
Right.
It's not about like becoming so averse to risk that we never actually get anything done, is it?
Right.
It seems more to me like it's about being very conscious and informed when we do decide to take those risks.
Yeah.
And something that our materials highlight here is that these decisions about risk, they should be made at the appropriate level of command,
Yeah.
which makes sense, right? The folks who are closest to the actual work, they're the ones who often have that granular understanding of the immediate risks and the best ways to handle them.
Mm.
But I guess, are there times where that immediate perspective might miss some of those bigger, longer-term consequences?
Absolutely. It's a great point.
Yeah.
While that person right there in the thick of it has that really critical info about those hazards right in front of them,
Yeah.
someone higher up the chain might have more of a grasp on those systemic risks or limitations on resources, or maybe even strategic priorities that need to factor in.
Right.
It's a balancing act. The principle stays the same. We don't take chances that aren't worth the potential gain.
Mm-hmm.
But figuring out what is actually necessary, well, that often needs input and decisions from the level that can best weigh all those factors.
Yeah.
And to give us a structure for this, our materials keep pointing to this 5-step risk management process.
Right.
So it's like a cycle that repeats: identify those hazards, assess those hazards, develop those controls, and make those risk decisions, implement those controls, and then we supervise and evaluate.
Okay, so that's 5 very distinct steps, and I think it would be good to get into each of them in detail to see how they all work together.
Yeah, definitely.
So let's just jump right into that first one, identifying hazards. When we're talking about identifying hazards, what are we really looking for here? Like, how specific do we need to get?
The goal, as our sources put it, is to really pinpoint those hazards with the most potential for loss. And by loss, we mean injury, damage to equipment, even environmental impact. And a really key filter here is to think, is this hazard already controlled well enough at my level or the level below me?
Mm-hmm.
If those controls aren't enough, that's where we need to focus. We can't go after every little thing with the same energy, so it's about prioritizing the threats, the ones that aren't already well managed.
That makes a lot of sense. Directing our energy and resources where they can have the biggest impact on safety.
Exactly.
But honestly, sometimes just starting that process of identifying hazards can feel a bit overwhelming. Where do we even begin to think about everything that could go wrong?
Well, thankfully, our materials give us this really handy and memorable prompt,
Okay.
ENERGY.
Okay, energy.
It's an acronym to help you systematically walk through those key aspects.
Got it.
So E is for environment.
Okay.
Think about the actual conditions where this work is happening. Is it hot, cold, wet? Is it a tight space? How about noise or lighting? Are those a problem?
Okay, so that's the E.
Then we have N for the nature of the operation, what's actually being done,
Yeah.
what tools are being used, what are the risks that just come with that kind of work.
Got it.
Then we have E again, but this time for experience.
Hmm.
What have we learned from past incidents, close calls, or even general knowledge about this kind of work?
Mm-hmm.
R is for resources.
Her.
We short on people, equipment,
Mhm.
materials. Could that cause problem?
Okay, resource.
Then G, that's for geography.
Okay.
The specific location, the layout,
Yeah.
tight spaces, uneven surfaces, anything that could cause a hazard.
Mm.
And finally, Y for the individual.
Okay.
Their training, their experience, how they're feeling physically and mentally, anything about them that can make them more vulnerable to hazards or affect how safely they work.
So, energy, that's honestly really clever. It's like a checklist, a way to systematically look at things instead of just relying on gut feeling. And then our sources actually go on to list a bunch of very specific hazards, particularly in marine engineering. It's like taking this idea of hazard identification and making it really real and tangible.
It is. They give you a ton of examples.
Yeah.
So like one of the big ones they mention is unguarded moving parts and machinery, exposed gears, belts, couplings, all that.
Yeah.
And of course, the risk of loose clothing, hair, jewelry, getting caught in those. That could be a really serious injury.
Right. It's like those split-second things that could have really big consequences.
Yeah, exactly. Then there's the sudden uncontrolled release of power systems, hydraulics, pneumatics, even stored electrical energy. Any of those can cause huge problems if they let go unexpectedly.
And then I'm seeing here they mention materials being ejected from machines during operation. Like I'm picturing metal shavings flying off a lathe or sparks from grinding. Eye protection seems pretty crucial there.
Oh, absolutely crucial. And they also talk about the risk of a machine starting up accidentally. Like someone's working on a piece of equipment, they think it's off, and then suddenly, boom, it powers on.
Right.
Really emphasizes why those lockout, tagout procedures are so important. That's something we'll definitely get into more later, but it's all about making sure that equipment is completely isolated before you start working on it.
Yeah. And it's not just the machines themselves, right? They talk about hazards in the workspace itself. Things like slips and falls, especially around those nips, those pinch points where rollers or rotating parts come together. Contact with sharp edges, whether on equipment or materials, that's another one. And then there are unsafe practices, like trying to adjust a machine while it's running or letting someone operate something without proper authorization.
Right, and that's a key point. It's not just about the physical stuff.
Yeah,
Human factors, procedures, they play a huge role.
absolutely.
And you're right, it's not just when things are running. They specifically list a lack of good preventive maintenance as a hazard. If equipment isn't checked, lubricated, repaired regularly, it's way more likely to just fail. And that could mean breakdowns, fires, injuries, all sorts of problems.
And actually, one of our sources has this section called Exercise by Ship's Staff.
Yeah.
And it really gives this great practical snapshot of the kinds of hazards you might find in a real marine engineering setting. It's almost like a scavenger hunt for potential problems.
It is. It's a really good example. So they mention things like oily equipment. Seems minor, right?
Right.
But that's a slip hazard, especially on those deck plates. Could lead to a nasty fall.
Yeah.
Then there's a grinder without its safety shield.
Oh, that's scary.
Yeah, that's a huge risk of eye injury from flying debris. A cut electrical cable that's been spliced back together, that's just an electrocution waiting to happen. Water near other cables, again, risk of shock. Drip hazards all over the workshop floor. Even something like a fire extinguisher blocked by other stuff.
Right, so it can't be used.
Exactly, useless in an emergency.
It is kind of sobering when you hear them all like that.
It is.
And it makes you realize how these hazards can be lurking even in routine places if you're not actively looking for them.
Right.
And they don't stop there. I'm seeing even more examples in the material.
Keep going. So they point out someone working with sparks, flying, but no safety glasses. Big risk of eye injury there. Someone standing on the top rung of a ladder, super unstable, much higher chance of falling. A leaking drum could spill on the deck, maybe even into a drain. Environmental hazard, plus another slip risk. Then there's recharging batteries in a closed space with no ventilation, could build up explosive gases, not having PPE readily available. A leak on the ground, again, slipping hazard. A ladder that's been repaired but maybe not so safely. Loose bottles and containers that could fall and cause spills or injuries. And even an undone shoelace as a trip hazard.
Wow, so it really is about paying attention to all these details at every level.
Yeah, vigilance is key.
Absolutely. And then they get into hazards that are linked to specific equipment, starting with portable power tools. What are some of the common dangers there?
Well, just like with the bigger machines, contact with moving parts is a big one.
Right.
But then you also have electrical risks with those tools. Bad insulation on wiring, faulty cables and plugs, all that stuff.
Yeah.
That's where shocks can happen. Then there's the guards, the safety guards. If those are missing or disabled, that's a huge problem.
Yeah.
And then there's simply using the wrong tool for the job. That can lead to the tool breaking, the work getting damaged, and you getting hurt.
And I think we often overlook how dangerous compressed air can be.
Oh yeah, it seems harmless enough.
Right.
But our sources actually point out some pretty serious risks. If you get a blast of high-pressure air in your mouth or eyes, It can cause really bad internal injuries, even blindness, and can even force air into your skin, really bad tissue damage.
That's scary.
Yeah, and even just forcing air into a cut, it can push contaminants in deep and cause all sorts of problems.
Okay, so compressed air, definitely not a toy.
Nope, definitely not.
And then there's specific machines like lathes. What are some of the hazards there?
One of the biggest risks with lathes is getting your clothing, hair, jewelry, anything dangling caught in that rotating workpiece or the moving parts of the machine itself. That can pull you in with incredible force, really, really bad injuries. Then there's the metal chips flying off during cutting. Again, eye protection is absolutely vital.
Yeah, definitely sounds like you need those safety glasses.
Absolutely. And of course, there's the risk of touching those fast-moving parts.
So lathes, lots of things to be careful about.
Lots of hazards, yeah.
And then grinding machines, they have their own set of dangers.
They do. Like if you're not holding the workpiece right against the grinding wheel, you can lose control, maybe get hurt. Then there's those work rests. If those are missing or not adjusted right, the workpiece can get caught or thrown.
Okay.
And then there's the grinding wheels themselves. Using the wrong kind for the material or a damaged wheel, those can shatter. Really dangerous. Grinding on the side of a wheel that's not meant for that, or grinding too high, or even mounting the wheel wrong, all that can put stress on it and make it more likely to break.
So it sounds like you really need to know what you're doing with those grinding machines.
Absolutely.
And I'm noticing here that they even mention something as seemingly simple as removing a pump for inspection or maintenance.
Yeah.
And they list out a whole bunch of potential hazards there.
Because even that, which seems straightforward, has its risks.
Right.
First of all, before you even touch it, there are electrical hazards.
Mm-hmm.
You need to make sure that power is totally isolated, locked out.
Mm-hmm.
Then there's usually pressure inside the pump or the pipes connected to it.
Yeah.
You need to release that safely before you take anything apart. And of course, pumps are heavy.
Yeah.
So lifting it can cause strains or other injuries.
Right.
And depending on what that pump was handling, there could be oil, chemicals, other fluids inside. So you need to protect yourself from those.
So even a task like removing a pump, it's not as simple as it seems.
No, you really need to be aware of those hazards.
Okay, so we've talked now about identifying hazards in all sorts of scenarios. It's a lot to think about, a lot of detail. But once we've identified those potential problems, the next big step is figuring out just how risky they are. How do we assess that level of risk?
So for that, we look at two main things. How likely is the hazard to happen?
Okay,
And how bad would it be if it did happen?
right. So likelihood and severity?
Exactly. So the likelihood, that's the probability. Our sources actually give us this whole probability table.
Okay.
So on one end, you have frequent.
Mm.
That means it's probably going to happen at least once a year. Then there's probable, meaning it'll likely happen sometime during the equipment's life.
Okay.
Then there's occasional, which means it could happen. Remote, meaning it's unlikely but still possible.
Right.
And improbable, meaning it's so unlikely we can pretty much assume it won't happen.
Okay, so it's a range of likelihoods.
Right, a whole spectrum.
Got it.
And then there's severity. That's all about the potential impact.
Mhm.
Our sources have the severity table, and it
Mhm.
goes from catastrophic at the worst end, meaning potential death or massive costs,
Oh.
and then all the way down to negligible, which is minor injury or illness and minimal cost.
Okay.
In between, you have critical, which could mean serious injury or big damage,
Okay.
and marginal, which is minor injury or damage. Both of these tables give really specific descriptions to help you figure out where a hazard falls on the scale.
So we have these two separate scales, probability and severity.
Exactly.
And to bring them together, our sources talk about this risk code table. It's like a grid, right?
It's a matrix. You look up the probability level and the severity level, and where they meet, that's your risk code. It's a number from 1 to 20.
Okay.
So a really low number, like 1 or 2, means high probability and high severity. That's a really serious risk.
Got it.
A high number means the risk is lower overall. It's a way to put a number on the risk so we can compare different hazards.
And I'm guessing these risk codes then get turned into those risk level descriptions.
Exactly. So we have that risk level table that links those codes to categories like intolerable risk.
Right.
Those are the ones with the lowest codes, meaning you shouldn't even start the work until the risk is brought down.
Okay.
Then you have substantial risk, which needs a lot of resources and quick action to fix. Moderate risk means try to reduce it within a certain time. Tolerable risk means it's there, but you don't need more controls right now, just keep an eye on it.
Okay.
And trivial risk is so low, you don't usually need to do anything specific.
So this whole system of probability, severity, risk code, and risk level, it seems really useful for prioritizing, figuring out which hazards need the most attention and the strongest controls.
It is. It's a framework for making those decisions.
Yeah, it's like a system. And our sources actually give us a good example of this in action with tank cleaning.
Oh, yeah, that's a great example.
They walk me through that.
So with tank cleaning, one big hazard is the atmosphere inside the tank. Could be toxic, could not have enough oxygen, it's a confined space.
Right. That's dangerous.
Yeah. So let's say we assess the probability of a hazardous atmosphere as likely, maybe based on what was in the tank before, or just our experience. And then we look at the severity. If something does go wrong, it could be death or very serious injury.
Yeah.
So we put likely probability and extremely harmful severity into our risk code table. That's probably going to give us an intolerable risk level before we do anything to control it.
Right.
So that tells us right away we need to do something big to reduce the risk before anyone even goes near that tank.
It really shows you how important it is to not just find the hazards, but to really think through how likely and how bad they could be.
It's all about understanding the potential impact.
Okay, so we've identified the risks, we've assessed them. What's the next step in managing this risk?
So the third step is all about developing those controls and making those risk decisions.
Okay.
The main goal of any control is either to get rid of the hazard completely, which is always the best option, or, if we can't do that, to bring the risk down to a level we could live with. And it's important to remember, as our sources point out, we don't just jump on the first control idea we have. We keep evaluating that residual risk, the risk that's still there after we put the control in place.
Okay.
We keep doing that until we feel like the benefits of doing the work outweigh the potential costs and consequences of those remaining risks.
Right, so it's like a balancing act.
Exactly, weighing those risks against the benefits.
Yeah.
And when we're thinking about what kind of controls to put in place, we have to be realistic. Can we actually do this control with the time, money, and people we have? It has to be doable.
Yeah.
And the controls should be as effective as possible at stopping accidents or making them less severe. But we also still need to be able to get the job done.
So it's a balance between safety and actually being able to do the work.
It is, finding that sweet spot.
And when it comes to actually making those decisions about what risk is acceptable, who gets to decide that?
Well, it depends on how risky the situation is. Our sources give us some examples. If the risk is high, it might need to go all the way up to a senior manager, like the company's superintendent.
Okay, so someone with a lot of authority.
Right, because the stakes are higher.
Yeah.
If it's a medium risk, maybe the ship's master or the chief engineer can make the call.
Okay.
And for those everyday lower-risk tasks, the duty officer might have the authority to say, yep, this risk is okay.
It's like a chain of command for risk decisions.
It is. It makes sure that the right person is making the call based on their level of responsibility.
So what are some actual examples of those controls? What can we actually do to address these hazards? Our sources have a ton of specific ideas.
They do. So one of the most basic is machine guarding.
Okay.
That's all about physically stopping people from getting to those dangerous moving parts.
Right.
And there are all kinds of guards. Fixed guards, they're attached permanently and just enclose the hazard. Interlock guards, they shut off the power if you open them while the machine's running.
Okay, so that's like a safety feature.
It is built right in.
Got it.
Then you have adjustable guards that can fit different sizes, pullback devices that keep your hands away from the danger zone, and two-hand controls, meaning you have to use both hands to start the machine, so your hands can't be near the moving part.
Then there's all that personal protective equipment, the PPE.
Right, that's your last line of defense.
Exactly.
And that covers a huge range. Basic stuff like hard hats and safety shoes. Then you have things like goggles and face shields for when there's flying stuff or splashes or even radiation. Safety harnesses to stop you from falling. Gloves to protect your hand from cuts, chemicals, heat, cold, all that. And ear protection when it's loud.
Yeah, there's a lot of different types of PPE.
A lot, and it's important to use the right kind for the job.
Absolutely. And then there are the procedures, those safe operating procedures or SOPs.
Right, those are crucial. We're talking about step-by-step instructions for using equipment safely. Our sources specifically mention SOPs for things like air compressors, pumps, lathes, grinding machines, drill presses, all that.
Okay, so it's like a guidebook for each piece of equipment.
It is. It tells you how to run it safely, what to check before you start, how to monitor it, how to shut it down.
Got it.
And then there's lockout, tagout, or LOTO. That's all about preventing surprises,
Okay.
making absolutely sure that a machine can't start up while someone's working on it.
Right. So you physically lock it out and put a tag on it,
Exactly.
so no one accidentally turns it on.
Right. It's a vital safety procedure.
And then for something like welding, there are controls that are specific to the welding process itself.
Absolutely. So for welding, a lot of times they'll preheat the materials before welding. That helps control how fast it cools and makes it less likely to crack.
Okay.
And they'll be very specific about what welding consumables to use, like the rods or wire. Those have to be the right type for the metals you're joining and the welding technique you're using.
So there's a lot of science behind it.
There is. It's not just sticking two pieces of metal together.
And actually, speaking of controls, we have that case study about preventing oil loss in bad weather.
Oh, right. The lubricating oil drums.
Yeah. That really shows how important it is to secure cargo properly.
It does. In that case, they only used nylon ropes to secure the drums, and they waited to transfer the oil to the storage tanks.
Okay.
So those drums were just sitting there on deck when the storm hit, and the ropes weren't strong enough.
So they came loose?
Yeah, they slipped, got damaged, oil spilled everywhere, big mess.
Yeah, not good.
Not good at all. So when they analyzed what happened, they came up with a bunch of recommendations for better controls.
Okay, so how do you prevent that from happening again?
Right, so they said transfer that oil into the tanks as soon as possible. Use a dedicated spot on deck for storing the drums, and make sure it has strong lashing points, maybe welded ones. Put the drums on pallets so they're not right on the deck. Use wire rope instead of just regular rope, and use turnbuckles to really tighten those lashings down.
Okay, so that's making sure they're really secure.
Exactly. No more slipping around. And use padding to protect the drums from rubbing and getting damaged. And maybe even cover them with tarps to keep the weather off.
So it's really thinking through all the different things that could go wrong.
And then they even said have a specific procedure for dealing with corroded drums because those are more likely to break.
Right, so that's really comprehensive.
It is. It's looking at every angle.
And then thinking back to that tank cleaning example, for hazards like toxic atmospheres, ventilation is key, right?
Oh, yeah, absolutely.
Yeah.
You need to make sure that air is moving, getting rid of those dangerous fumes.
Yeah.
And before anyone goes in, you have to test the atmosphere.
Right, make sure it's safe to breathe.
Exactly. So that's another example of a control, making sure the air is safe.
Okay, so we've talked about a ton of controls, from physical guards to procedures to PPE to really specific stuff for different tasks.
It's a whole toolbox of options.
And once we've picked the right controls for the job, the next step is actually putting them to work.
Right, that's implementation. Step 4.
This is where all that planning turns into action. The rubber meets the road, so to speak. Because it doesn't matter how good our controls are if we don't actually use them.
That's the key. It's all about making it happen in the real world.
And our sources have some good examples of what that looks like in practice.
Oh, yeah. They give us some real-world scenarios.
So tell me about those.
So, like, one example is having those standing operating procedures, the SOPs, and night orders. Those are written instructions for how to do things, especially routine tasks.
Okay, so that's like the documentation.
Exactly.
Making sure everyone knows the proper procedures.
Right. Then there's briefings and debriefings before and after tasks.
Mm-hmm.
That's where you talk about the risks and make sure everyone knows the controls and how to follow them.
So communication is really important.
Oh, absolutely.
And training, too.
Right. Training is key. People need to have the knowledge and skills to work safely.
Yeah.
And drills.
Yeah.
Practicing those emergency procedures.
Mm-hmm.
That helps people remember what to do when things go wrong.
It's like a fire drill, but for all sorts of emergencies.
Exactly. Preparing for the unexpected.
And sometimes it means actually getting new equipment with better safety features.
Yeah, that's building safety right into the design.
And I'm seeing here they mention pre-start checklists for machinery.
Right, like for compressors, engines, pumps.
So before you even turn it on, you go through the checklist.
Exactly. That makes sure those essential safety checks are done every single time.
And then there's the permit to work systems.
Yeah, those are for the really high-risk stuff. Working up high, doing hot work, things like that.
So you need special permission to do those things.
Right, because they're more dangerous.
Got it.
So the permit system makes sure those tasks go planned out, the risks are assessed, and someone's supervising.
That makes sense. And then there's planned maintenance.
Mm-hmm. That's about preventing problems before they happen.
Right.
Keeping equipment in good shape so it doesn't break down and cause hazards.
And using the right tools for the job.
Absolutely. And making sure those tools are well maintained, too.
Mm-hmm.
A broken tool is a dangerous tool.
And even just handling materials safely.
Right. Lifting, carrying, storing things properly.
Yeah.
All that can prevent injuries and spills.
So implementing controls, it's really about making sure all those safety measures are being used.
Yeah, it's putting those plans into action.
And that brings us to that final step in the cycle, supervision and evaluation.
Step 5, making sure it all works.
This is where we see if those controls are doing their job, right?
Exactly.
Right.
It's not enough to just set up the controls and walk away. We have to make sure people are following them.
Mm-hmm.
And we have to check if they're actually effective.
So it's ongoing. It's not a one-time thing.
Right, it's a constant process. Our sources really emphasize that risk assessment isn't static. It's always evolving.
Okay.
We need to review and update our controls whenever things change. Maybe the conditions change, or we have new safety goals,
Right.
or we get new procedures, new working methods, new materials, or if any equipment gets modified, anything like that, we need to reassess.
And I'm seeing here that our sources talk about using tools like risk assessment registers and shipboard risk assessment forms.
Yeah, those are great for documenting the whole process.
So they're keeping track of everything.
Exactly.
Yeah.
From finding the hazards, to assessing them, to the
Mhm.
controls, to the results of our evaluations, all that gets recorded.
Okay.
And the management team, along with that multidisciplinary team, the MT, they're really key in this whole supervision and evaluation process.
They're the ones making sure it's all happening.
They are.
And when it comes to actually finding those areas where our risk assessments might need updating, what are some of the methods they mention?
So they talk about doing those regular inspections of the vessel,
Okay.
walking around, looking for hazards, looking for unsafe conditions. Then there are those industrial hygiene assessments.
Okay.
Those are all about checking for chemical and physical hazards in the workplace.
Right. So that's like air quality, noise levels, things like that.
Exactly.
Yeah.
And then there's job safety analysis. That's where you break down a specific task step by step and figure out the risks at each step.
Okay.
And then there's encouraging employees to report any hazards they see. That's really important.
Yeah, they're the ones on the front lines.
Yeah.
They often see things that others might miss.
Right. So their input is crucial.
And then there's looking at all the safety data, incident reports, near misses, all that.
They can reveal patterns and maybe show us new hazards we didn't even know about.
So it's about constantly learning and improving.
It is. It's an ongoing process.
And when we do review those controls, what are some of the key questions we should be asking?
Well, first of all, will these controls actually